Hello, hello. Remember that Miss Henchman is doing her training for IB, and so that's why you are listening to this video of the lesson I would have taught you over Zoom. Remember that listening this video through to the end, answering the questions counts as your attendance for today. All right, folks, so we are starting into Unit 4. Unit 4 is all about angle and triangle relationships. We've already started to look at some of our triangle relationships, and now we're going to be switching a little bit into our angle relationships. So the first set of relationships we're looking at is when we have parallel lines that are cut by a transversal. So we want to be able to identify and recognize the angle relationship itself and actually name it. And then we also need to be able to set up a equation based off of the angle relationship. For these notes, it's going to be really, really helpful if you have 3 highlighters, markers, color pencils, crayons, something that you can mark with, obviously your notebook paper, and then if you are a perfectionist like me, a ruler or a straight edge. So just some quick vocabulary that we need to be aware of. So we're talking about parallel lines. So understanding that normally you can eyeball it, but many times you would have markings, little arrows here to show that these two lines are parallel. So Q and R, these are parallel lines. And then we get this idea of a transversal. So a transversal is just a line that cuts through. So line P, this one would be our transversal. So we've got this transversal that's cutting through here. And again, that's cutting through your parallel lines. And we're going to be looking at the angles that are created when you have a line, this transversal, cutting through these parallel lines. We're going to also be talking about things like interior and exterior. So if we are talking about interior, we're talking about the space inside the parallel lines. So right here, this would be interior. We also talk about exterior. So that would be, so again, interior, let me go ahead and highlight here. So interior would be everything in between the parallel lines. And then your exterior would be everything outside of your parallel lines. So above here would be exterior. And then also below here would be exterior. And again, if you want to highlight with me, we would say this entire area above this parallel line and the entire area below this parallel line. So it kind of looks like a sandwich, inside would be the interior and then exterior is going to be on the outside. So that's a little bit of our vocabulary. We will still sprinkle in some more, but that's some of your just basic key vocabulary components. All right, the first type of relationships we're going to look at are relationships that are congruent. And of course, we need to remember that the word congruent means that they are equal. So we're going to be looking at vertical angles. So vertical angles are angles that are across from each other. And they're found when you see an X formed in a figure. We also call these the kissing angles, and I'll show you why in a moment, which seems kind of silly, but we call them the kissing angles. And that's because when we make this X that gets formed, if you can imagine, this angle right here is kissing this angle right here. So if you can imagine, like, I don't know if this is some sort of like fish and this was a fish, I don't know, some sort of animal here, that these would be kissing each other. Maybe they'd be happy. I don't know. That looks like really bad smiley faces, but they would be kissing each other because they're like across from each other. So we're going to be looking for angles that are across from each other. There's an X that's going to be formed. They're going to be kissing, and we call these vertical angles. And vertical angles are congruent to each other. So let's look for some angles that are across from each other. So for example, angle H is across from angle J. So those would be vertical angles. We could also say angle K is across from angle I, and those would be congruent to each other and they're vertical angles. We could also say that with M and O and with N and L. So making sure that we understand those angles that are across from each other are equal to each other. So again, as an example, angle K would be equal to angle I, and angle H would be equal to angle J, just to kind of name a couple there. Next, we have corresponding angles. So corresponding angles are angles that are in the same position. Of an intersection. So if we notice here, because I've got my parallel lines and then I've got my transversal, notice how we almost create like two intersections. We've got this intersection here, and we've also got an intersection here. So we're going to find that there are angles that are in the same position. So for example, if I'm looking at this intersection, the upper left would be O. Little smiley face there. So that would be upper left. And so if I look at the next intersection right here, upper left would be H. So I know that H and O are congruent to each other. And the reason why they're congruent is because they're in the same position, which is what we call corresponding. Notice if we then look at like lower right side, so we were looking at M. So M would correspond, if we're looking at this intersection lower right, well, the next intersection lower right would be J. So another example would be that angle M is equal to angle J. All right, we have two more sets of congruent relationships. So we have alternate exterior angles and alternate interior angles. So first, let's look at this word alternate. So when we're looking at the word alternate, we are describing angles in relation to the transversal. So we know that our transversal is right here, line P. And if we're talking about alternate, we're talking about alternate sides of the transversal or opposite sides of the transversal. We then have the word exterior, and we talked about that a little bit earlier. Exterior would mean on the outside of the parallel lines. Now, another trick that some students like to be able to figure out like interior and exterior is I always tell them to find a Z. Like quite literally, find the letter Z in your picture. So for example, if I were to look at this picture, I could say, oh, well, right here is my letter Z. And so sometimes that helps us to see what's on the inside and what's on the outside, and also to see what's opposite sides of the transversal. So if I am looking for alternate exterior angles, that means I need to be on opposite sides of the transversal. So think about like your left and right side, opposite sides, but I need to be on the outside of the parallel lines, aka outside the Z. So if I'm thinking about outside the Z, it could be H, I, N, or M. But again, they have to be alternates. So it can't be M and I because those are on the same side. They're both on the right side. And it can't be H and N because that's both on the left side. So if we're talking about alternate exterior, that would be like H and M because these are on alternate sides of the transversal and they're on the outside of the Z. So we could say that angle H is equal to angle M. We could also then say N and I would be congruent because again, they're on opposite sides. One's on the left, the other one's on the right of the transversal. And they're on the outside of the Z, aka outside the parallel lines. So again, we could say angle N is equal to angle I. All right, let's go ahead and look at alternate interior. So the same idea, except for now interior, meaning we want to look inside parallel lines or inside the Z. And again, alternate, meaning opposite sides of the transversal. So if I'm looking on the inside here, that could either be K, J, O, or L. So for example, if I take K right here, K would be on the left side. I can't use O because that's also on the left side. And it needs to be opposite. Now you could say, though, that it needs to be alternate interior. So looking right here at K, so that needs to be with L. So alternate sides and on the inside here. And also if you just look at the angle, you can kind of tell, okay, this is an acute angle, this is an acute angle. Okay, those two, they do visually look the same. So we could say angle K is equal to angle L. We would also then be able to say O is then congruent to J, because again, alternate interior. So angle O is equal to angle J. All right, so that is all of our angle relationships that are congruent. Now we're going to switch gears and look at angle relationships that are supplementary. Now, if we remember from back in middle school, the word supplementary, hopefully we know that that means that adds up 180. So we're looking at a couple of supplementary relationships. The first one is a linear pair. For a linear pair, we need to look for adjacent, and adjacent means next to. So we need to look for adjacent angles that create a straight line. Because if we think about it, a straight line itself is 180 degrees. Okay, so let's look at again our parallel lines here that are cut by our transversal. And to be honest, there are so many sets, like linear pairs in this picture, but let's pick out a couple of them. So I could use this parallel line right here and say that H and I are a linear pair because if we notice this angle I plus this angle H create this straight line of the parallel line here. Quite literally, their angles create this straight line. So in this way, because it's supplementary, we would say angle H plus angle I is equal to 180 degrees. All right, let's go ahead and look at one more pair. So let's look at L. So L would be linear with M. because again, these two angles together create the straight line that represents our transversal. So we could also, again, another example would be that angle L plus angle M is equal to 180 degrees. All right, let's look at two more supplementary relationships. So we have consecutive exterior angles and consecutive interior angles. So let's first look at this word consecutive. So consecutive means same side. And what we're referring to is the same side of the transversal. We're still looking at the word exterior and interior, and we're still referring to either inside, excuse me, this one would be outside. The parallel lines. Or what letter did I tell you to look for in the shape? I could also help you see it. The Z. So either outside the parallel lines or the Z. But this time, instead of doing alternate sides of the transversal, we're looking on the same side. So let's go ahead and find our transversal here. And let's find our Z. So our Z would be right here again. All right, and we're looking for exterior, so I need anything that's on the outside of the Z or outside of our parallel lines. That could be H, I, N, or M, but it needs to be on the same side of the transversal. So that means if I'm talking about H, well, along the same side of the transversal would be N, and they're both on the outside. So we could say that angle H plus angle N would equal 180 degrees. We could also then use I and M, because again, they're on the same side of the transversal and on the exterior. So we could also say angle I plus angle M is equal to 180 degrees. All right, let's look at our consecutive interior. So again, we're looking on the inside of the Z. So if I was looking at K here, I need to be on the same side inside, so that would be O. Because again, these are both along the transversal and they're inside the Z. So we would say, okay, angle K plus angle O adds up to 180 degrees. And then hopefully you can also see right here, angle J and angle L would be on the same side and inside the Z. So angle J plus angle L is equal to 180 degrees. All right, so those are all of our angle relationships. You do need to be able to set up all your equations. And sometimes this is where students struggle. They can recognize the angle, but they're like, I'm not sure whether I should make them congruent to each other or make them supplementary. So this is a little trick that teachers show students. This is not necessarily like a mathematical theory or anything special like that. It's just a little trick that people have come up with. So if I'm looking at my transversal, I'm looking at my parallel lines. So what we're going to do is we are going to find an intersection. And I'm going to put a line through one set of vertical angles. I'm going to go to the next intersection. I'm going to put a line through that set of vertical angles. Now, once angle O has this line through it, I can't put any other symbols there. Same with angle M, H, or J. On the other set of vertical angles, I'm going to put a dot and a dot. So notice that for an angle, it either only has a line or it only has a dot. I'm going to do that to the other set of vertical angles here. And notice again, this should be in the same position. So dot and then dot. So once you draw correctly your lines and your dots, and notice again, an angle would only get either a dot or a line, not both, then we have a little bit of a saying here. So if they are congruent relationships, we would say a line is equal to a line or a dot is equal to a dot. So we could also say then that means angle N is equal to angle I, which is equal to angle K, which is equal to angle L. All four of these angles are all equal to each other. If it is supplementary, we would say a line plus a dot is equal to 180 degrees. So any angle that's labeled with a line and any angle that's labeled with a dot, if we added them together, they would always equal 180 degrees. So hopefully that helps you with not just your naming, but then also a little trick in order for you to figure out whether your equation should be congruent or supplementary. The last thing that we're doing is just checking our understanding. I highly encourage you to pause the video and try to think for yourself about where your picture would go and what relationship is represented. Obviously, once you're done, click play, and that way you can check your work. So let's look at this first one here. And remember that we could be using things like finding our z. Now this one might look a little weird because our parallel lines are vertical. And for some of us who are visual learners, this might be a little bit easier. So for me, I found the z going kind of this way. So notice that these two angles, one's on the inside and one's on the outside of the z. So it can't be alternate interior and it can't be like alternate exterior or even same side interior, same time exterior. That won't work. So if we think back to like our angle relationships, it could either be like a vertical or maybe a linear. Well, hopefully we recognize that X and 91 are all on the same line right here. So if they're on the same line, they would be linear, and linear would be supplementary. And again, you could be using your notes to figure that out. I'm going to go ahead and move that over here, and we're just going to put that this is a linear pair. So if it's a linear pair and it's supplementary, we would say X plus 91 is equal to 180. And we would just subtract 91 on both sides in order to get X. And so 180 minus 91 is 89. So we know that X is equal to 89 degrees. All right, let's look at another one. So let's look at this one right here. So again, I'm going to try to find my Z. And again, if you are not a visual learner, still try to do this because it is helpful once you get the hang of it. You just kind of have to practice. All right. So this one might be a little bit easier for us because we've got the parallel lines going horizontally, and so it's a little bit easier to see the Z. And then if I'm looking at our angles here, notice how this angle is on the outside of the Z, and this angle also is on the outside of the Z. Notice if I'm looking at my transversal, this one's on the left side of my transversal, this one's on the right side of my transversal. So that means this relationship is alternate exterior. An alternate exterior means that it would be congruent. So this one is congruent. The relationship, again, is alternate exterior. And if it's congruent, well, if this side is 107, this side's also 107. So X is equal to 107 degrees. All right, let's look at another one. Let's look at this one down here. So again, a little bit easier for us to find the Z because our parallel lines are horizontal. Now notice for these angles, if I'm looking at my transversal here, this one is on the right side of the transversal, and this one's also on the right side of the transversal. And they're both exterior. They're both on the outside of the Z, aka outside the parallel lines. So that means that this would need to be same side or consecutive exterior. And that relationship would be supplementary. Okay, so this one would be supplementary. And again, this is going to be on the same side exterior. So we would call this consecutive or same side exterior. And again, we would know that these two angles are supplementary, so they add up to 180. So 109 plus x is equal to 180. Subtract 109 from both sides, so 180 minus 109, and that's equal to 71. So x is 71 degrees. All right, let's look at another one. So let's look at this one up top. So this one, if I'm drawing my z, again, kind of weird because my parallel lines are vertical. So if I draw my little z here, okay, so notice again, we've got this situation where I've got an angle that is on the inside of the z and an angle that's on the outside of the z. So that means it can either be a linear pair or it could be vertical. Well, hopefully we see that these angles are across from each other. And if they are across from each other, then they are vertical angles. And vertical angles are congruent. So this one is a vertical angle. And if they are congruent, that means x is equal to 77 degrees. All right, let's look at this next one. So we need to find parallel lines. Okay, find our z. So I notice a z like right here on the side. Now notice that, okay, I've got one angle that's on the inside, one that's on the outside. Okay, so it could be linear, it could be vertical, or it could be corresponding. Well, it can't be linear because even though these are on one line, they're not like next to each other. Like this x isn't right next to 1010, and this x isn't next to 1010 over here, so that doesn't work. And they're not vertical because I don't have an angle that's across from it. So notice this is corresponding because they're in the same position. If I'm looking at this intersection right here, and if I'm looking at this intersection right here, notice this x is to the lower right, and notice this 110 is to the lower right. So if they're in the same position, that means they're corresponding and they are congruent. So these would be corresponding. And if they're congruent, x is equal to 110 degrees. All right, last but not least, let's find this z here. All right, found our z. Notice that both x and 85 are on the same side of the transversal. And they're both on the inside. So again, they're on the same side of the transversal and they're on the inside. So that means it's consecutive interior. It's again on the inside and on the same side of the transversal. So that would be supplementary. And again, that relationship here is going to be consecutive or same side. And this is going to be interior. And if this is supplementary, that would mean that x plus 85 is equal to 180. And then if I subtract 85 on both sides, 180 minus 85 is 95 degrees. All right, make sure to go back and watch anything that you need and take adequate notes. We will be doing kind of the next level of these problems tomorrow. These problems that I just went over are a little bit easy for what we need to be at, but we got to start someplace. Hope you have a great rest of your day, and I will see everyone tomorrow.